All right, so here's your quiz for Friday. Uh, don't be the kid who misses number one. Like, just don't be that kid. Like, you can seriously don't be the kid who misses this. Like, look at your faceplate on your TI-84. Ln has an understood base of E. Now, I might ask log of X. I might. Understood 10. Okay, so anyways, don't be that kid. Number two, a rule that you memorize for a logarithm of argument A, the argument is bigger than 0. It's positive. So 2x minus 1 is greater than 0. And this is a two-step equation. I don't know why you can't do this, but I'm not you. We add 1 to both sides, and we divide by 2. X is greater than a half. How we write that, we could do things like set builder notation, all values of x such that x is greater than a half. Or we could use interval notation. We could just say 1/2 to, I'm just going to write it. And again, please use the symbol. Please use a symbol. Please use the infinity symbol. Don't just copy me. Don't do it. Number 3 is a graphing problem. I wish I would have put a grid here on this one, but I didn't. So when it comes to graphing, you've got to recognize your shifts. This is a right 1. We've been over this, and this is an up 2. The shifts are very important, okay? Right 1, and then up 2. This guy right here is your horizontal asymptote. It is the line that you cannot, shall not pass. So let me talk about some stuff over here. Your horizontal asymptote's at y equals 2, and you cannot pass that. The right 1 has to deal with your table. Since you went right 1, you're going to start your table off with a 1, and then you're just going to add 1 for the next entry, which makes it 2. And then you're going to fill out your table, okay? So I'm going to plug in a 1. 3 times 4 to the 1 minus 1 plus 2. 1 minus 1 is 0. And we have hopefully memorized right now that anything to the 0 is 1, so this becomes 3 plus 2, which is 5. All right, now we're going to plug in a 2. So 3 times 4 to the 2 minus 1 plus 2. This is going to be 3 times 4, because 2 minus 1 is 1, right? 4 to the first is 4 plus 2, and that's going to spit back a 14. So the points are kind of funky, but whatever. I've got to go to 1, 5, 3, 4, 5, and then I've got to go to 2, 14. 6, 7, 8, 9, 10, 11, 12, 13, 14. Now, when I actually do your quiz, I'll pick something with smaller numbers, so don't be too concerned. This is a growth equation because the growth factor, 1 plus r, is bigger than 1, so this thing is going to grow. And there you go. It had a horizontal asymptote at y equals 2. You know I'm going to ask more than that. It has a domain of negative infinity to infinity, and it has a range of 2 to infinity. Hopefully you guys have caught on to that by now. We've had several examples where I've been asking you to do this and made sure you can do it, so hopefully you've got it ironed out. Don't just look at your calculator. 4, because you won't get it right. 4 is rewrite this log using 3 different ways. You need to know your changes of base. A logarithm base b argument a can be written as log a over log b, or it can be the ln of a over the ln of b, or it can be a log of a chosen base of a over a log of a chosen base of b. So it says you pick the base, okay? I'm going to pick 5. So when I do this one, it's log base 5 of A over log base 5, oh, not A, more on Milbrath. A is 15. This is A, this is B. 15 over log base 5 of 3. You pick something else. Do a frowny face, do a happy face. I don't care. Just pick something. It can be a different letter of the alphabet. I don't care. All right, so we talk about the log method. We'd have log 15 sitting pretty over log 3. Talk about the ln method, ln 15 sitting pretty over ln 3. That's how you do it. Find the inverse of this function, 2 times 3 to the x minus 1 add a 4. So I've got a little bit of time here. Let's talk about the steps here on writing an inverse. There's just 3 easy steps. Step 1, we swap x and y. Step 2, we resolve for y. And step 3 I call notation. We're going to use f raised to the negative first of x, read the inverse of f of x. How you say things means a lot as to your level of understanding. But those are the 3 steps I'm going to use. By all means, write it down. It helps to memorize. And memorization is the key to learning. For some reason, we have gotten away from that in education, and I refuse to get away from that because you can't do math without memorization. If you can't add or multiply or subtract because you didn't bother to memorize it, you're in trouble. So anyways, swap x and y. This is y. It becomes x. And that x becomes a y. Now, we have to isolate this somehow, okay? So we're going to isolate the base of 3. We're going to subtract 4. X minus 4 equals 2 times 3 to the y minus 1. Then we're going to divide both sides by 2. You'll notice I'm not doing this anything fancy, like I'm not pushing buttons in a calculator. I'm not trying to figure out what 4 over 2 is. That's what it is. It's x minus 4 over 2. That has to equal 3 to the y minus 1. So at this point in your life, you need to be identifying your pieces. You have a base, you have an exponent, which means that all of this is your argument. And do remember that log is bay. That's the kicker. Log is bay. The inverse of an exponential function is a logarithm. So you just need to get into position to write that logarithm. Your logarithm's base is going to be 3. Its argument is x minus 4 over 2, and it's going to equal y minus 1. And we're almost done with step 2. We have to add 1 to both sides. I wish the common sense of algebra would just start clicking with some of y'all. I just keep doing opposites. I play an isolation game, and I do opposites. Like, that's all it is. That's all it is. Algebra is isolation and opposites. That's all it is, isolation and opposites, nothing more. It's so easy. Quit overthinking it. As soon as you learn what an opposite of something is, you can now master it. All right, moving on to 6. So in 6, you have to understand the understood. I say that a lot, but I don't think you understand what I mean, which stinks because you're supposed to. Understood base of 10. And it is your base, which means this is your argument with an A, which means this is your exponent. So we are going to do a process called exponentiating. We're going to exponentiate. 10 to the 5th is 3x minus 1. If you don't know what 10 to the 5th is, you're going to have a TI-84. Like, if you don't know that that is 100,000, you can go to your TI-84 and you can type in 10 to the 5th. It will not judge you, but it's 100,000. I told you it was. I wasn't wrong. We're going to add 1 to both sides. 100,001 is 3x. And we're going to divide by 3. I would absolutely be shocked if that cleaned up, but who knows? It's been a long day. Let's just make sure I'm right. It could be divisible by 3. Long shot, but it's not. I don't want the decimal. That's my answer. 100,001 over 3. All right, and here we have an e. What we're going to do is we're going to isolate, and then we're going to do the opposite. And the opposite of an exponential is a logarithm. So we're going to isolate, and we're going to do opposite. That's all we do. Do the easy stuff first. 14 minus 5 is 9, so 3e to the 4x minus 2 is a 9. Divide out the 3. E to the 4x minus 2 is a 3. And now we're going to convert to a logarithm. Convert. Log is base, exponent, argument. So we are in possession of a log base e, whose argument is a 3, and she equals 4x minus 2. Log base e is written as ln. The opposite of subtraction is addition, and that equals 4x. Divide through by the 4, and you're in business. Now, I know that that number means nothing to you guys because you just want a number you can interpret. So if I'm curious what this is, let's see, the safest way to do this, when we want to be safe, is math num n over d, ln 3 plus a 2, sitting pretty over a 4, 0.7747. All right, I still got 15 minutes. Number 8, do these things represent growth or decay? So you've got two things here. Your growth ideas are that the amount after time passes is the principal times 1 plus r to the t. And I want you to realize that this means that the base is greater than 1. Your decay is that the amount after time passes is the principal times 1 minus r to the t. And this means that the base is less than 1. So this is my base. The base equals 3. So that has to be growth. So anything with a decay is gone. Now the rest of us, this is common sense. Since the base is 3, we triple as we move right. All right, here we have 2/5. That's my base. My base is 2/5. And 2/5 is less than 1. So this must be decay. So anything with a growth, I strike through. You'd be surprised at how many kids would mark decay and then pick the 3. 3 is not a base. 3 is the letter A. I don't know if you remember that or not, but this is A. That's what she is. So anyway, this decay, the 2/5 tells us the next value of the function will be 2/5 of the previous values. Now, I'll include at least one of these on the test. I don't know if it'll be growth or decay. I hadn't made the thing yet. But I will cut the test down just a little bit from 19 questions, probably around 16, maybe 17. It's not a test, it's a quiz. This particular question, I think about half of y'all got it. It might have been a little over, but it was roughly 1/2 students got it, which isn't horrible. We can do better. I'd love to see that hit 80, 90%. There's some kids who just aren't going to get it, but I'd love to see the vast majority of you get it because it's not hard. The rest of the kids who aren't going to get it, they're just not going to put in the time to do it. So we're going to take a look at our TI-84. Good old y equals your best friend. Now, I actually want this one to be a completely factored problem. A little bit different than last time, but the same stuff is more or less true. We're still going to do synthetic division. We're still going to use a TI-84 to get zeros. And I promise you that this one is a little rougher than the one that you're going to have on your quiz because I know this one has a zero that's a fraction. So anyways, I'm going to do my Zoom 6. And here's a nice answer. Like that is clear. That says x is -2. So I know that's true. This one is not so nice. So to get this one, we're going to put a 0 in y2. And you have to put that there if you want to use the intersect feature. Then second, trace 5. I always have at least 5 or 6 kids a year say, Milbrath, there's nothing to intersect with. Well, that's because you didn't put the equation in the y2. Like, use your brain, kid. Anyways, now that I've got a second line there, second trace 5, get my little cursor close to what well, as close as you can. Press enter 3 times. So you get this decimal point 33333 forever, you know. And the truth is, and I know a lot of you don't, but you are expected to know that 0.333, the bar, is 1/3. So from my calculator, I got x equals -2 and x equals 1/3. So I'm going to do a little good old synthetic division. I'm going to do the -2 first. So I have a 3 for a coefficient, a 5, a 25, a 45, and yes, signs matter, a -18. I'm going to drop the 3. -2 times 3 is -6. 5 plus a -6 is -1. -2 times -1 is 2. 25 plus 2 is 27. -2 times 27 is -54. 45 plus -54 is -9. -2 times -9 is 18. Remainder of 0. Because I had a remainder of 0, and this isn't the first time you've seen me do this, I continue. And notice I stopped the divisor before that 0 because that 0 is a remainder. I sound like the Micro Machine guy. He was a commercial for Micro Machines back in the 80s and 90s because I'm talking too fast. A third of 3 is 1. -1 plus 1 is 0. A third of 0 is 0. 27 plus 0 is 27. A third of 27 is 9. -9 plus 9 is 0. Remainder, constant, x to the second. All right, so let's see what we're supposed to do. The question says, if you bothered to read it, was to completely factor. So here's what I've done so far. I have an x plus 2 as a factor, and I have this x minus a third because we changed signs. And then I've got this piece left over. It's 3x squared plus 27. So I'm not done. I know 3x squared plus 27 can still be worked with. But to factor, I need to know zeros. Oh, by the way, there's more things we can do. And we're going to clean this up a little bit. But 3x squared plus 27 is going to be a factor. It is going to be a 0. We're going to divide. Well, sorry. First, we're going to move that 27 over. Then we're going to divide that 3 out. We're going to take the square root of a -9. We're going to include the plus or minus symbol. And I know, and you know, because it's been shown to you, that that is going to be plus or minus thrice I. Okay, so what do we have so far? We have x plus 2, we have x minus a third, and then we have the plus and minus 3i. So x minus 3i and x plus 3i. This is a complete factorization over the complex number system. Now remember I said a was 3? Let's throw that 3 there and let's distribute it. Oops, too far. Let's distribute it to this guy to make this guy look prettier. X plus 2. And again, the one on your quiz is going to be much easier. X plus 2, 3x minus 1. X minus 3i, x plus 3i. Complete factorization over the complex number system. A college algebra skill, which some of you guys will take next year. Also a skill in pre-calculus, which some of you will take. Not a skill in bridge math. So if you don't like what you're seeing, you don't want to see me next year, because next year I'm your proctor in college algebra, and next year I'm the guy who teaches pre-cal, because ain't nobody else going to do this job. So if you don't like this, don't take me next year. All right, 11, basic function notation. Now this one disappointed me on the last test, to be 100% honest. Like I was disappointed. Hopefully I spelled that right. I was disappointed. And you should be too, because this is too easy to miss. It is too easy. So we work our way out Right? Maybe you're not listening. Maybe you're just being a blind copier. But we're going to find f of 3 first. So f of 3, well, this is kind of a funny one. This is g of f of 3, is going to be the square root of 2 times 3 minus 4. Interesting. Notice how I have this done. Work your way out. It's going to be the root of 2 times 3 minus 4. So that's going to be 6 minus 4. It's root 2. So now that I've found f of 3, I'm thinking, okay, it's g of root 2. Okay, well, that's easy. 3 root 2 plus 3. I had probably 4 or 5 kids express this thing as a decimal. Do not express as a decimal. Decimals are not simplified. They are rounded. They're wrong, technically, because they got rounded. 12, another inverse. We just did an inverse not too long ago. Here's another one. The 3 steps, go back. If you done forgot your 3 steps, went too far. Oh, I've already erased them. But anyways, there were 3 steps here that hopefully you wrote down. Swap x and y. Resolve for y. Profit. You're probably like, profit? What do you mean by profit? No, brother, that means you're done. You got your points. You profited. You know how to do something. Moving forward, y becomes x. There's a little e there that's understood that I'm going to put there. Y minus 3 plus a 7. Now we're on step 2. So we're going to subtract 7. Remember, we're playing the isolation and opposite game is all we're doing. And now we're going to convert the logarithm into an exponential. Base argument, this must be my exponent. So e to the x minus 7 must equal y minus 3. And now we're back to the opposite game. We're going to add 3 to both sides. E to the x minus 7, could have swore I switched over to black there, plus the 3, still could have swore I switched over to black there, is equal to the inverse of this function. The inverse of y is just by default f to the negative first of x. Down to 6 minutes. You invest $500 into a savings account that pays 8.9% interest compounded continuously. You see that word continuously? This means you use ace of t equals p e to the rt. Good old PERT. Now, there isn't an example of anything like this in the real world. No banks do continuous interest. Credit card companies do 365 compounding, but no bank uses continuous interest that I've ever heard of. I guess that's technically could be true, but I've never heard of it. Anyways, we're going to plug in. We can identify our principal, 0.089, for those of you still struggling with that, and there's a handful. Times 20. I even said use PERT. Somebody will still use the wrong blasted formula. 500. Let's see here. I don't know why I put up parentheses. E to the 0.089. And I just want to know what's going to happen in 20 years times 20. And that should have technically been a 22. Ace of 20 is, well, let's see. I'm sure there's a handful of you who have yet to push the E button on your calculator. You probably will not push the E button on your calculator because you'll just leave it blank. Because that's what you do. $2,964.93. This is money too, by the way. Don't throw away those pennies. I got time for one more and then I got to run. Actually, I do not have time for this one. So, there's the first part. I'd love to say I hope you enjoyed, but you and I both know you did not enjoy this. You were forced to do this. Ha!